all the research that is happening, including research that can be done by 19 and 20-year-olds that many people think is not possible. So this is a day that we really celebrate our activities. As you all have heard many times, IIIT Hyderabad calls itself a research university with a strongly research-based undergraduate program, not just research at the master's or PhD levels. And we have proof of that is we have very large groups in many of our areas, consisting of PhD students, master's students, outside interns, as well as large number of BTech students who learn the craft here. And we have also have the distinction as a result. Strong undergraduate research has resulted in our students, including the undergraduate students, going out to across the world to the top universities, including CMU or MIT or Stanford, etc., and continuing their research or going on to be into the product groups and research groups in companies, etc. So our diaspora, our research diaspora is very strong. The difference is with IIIT Hyderabad diaspora is that all of them have started their research journey right here in this place. They worked on their first projects here. They probably had their first publication from here, and then they are continuing on that. So that sets us apart from, to other institutions where they don't get to do research while they are undergraduates in those institutions. So I have constantly been engaging with the computer vision diaspora that I helped create, our CVIT or computer vision lab, the diaspora, we call it IIIT Vision Diaspora. That is typically in a conference like CVPR or ICCV, there are 50 to 60 members of the diaspora working there, presenting their papers. They may be representing multiple universities, multiple companies, and a good number also representing IIIT itself. So this is the seed of research that we sow into the minds of the young undergraduates as well as masters and PhD students, and that becomes a big force in the world. Today is also March 8th, International Women's Day. So we should also celebrate how the women in research at IIIT and elsewhere. I have got the statistics from IIIT that in our last 25 plus years, about 350 women students have graduated with a master's, a thesis-based master's degree, MS by research degree. This includes about half as dual degree students who got a BTech and master's integrated, and the others MS, they came from outside with a bachelor's and got their master's degree here. We also have graduated about 75 women PhD students who are all over the country, all over the world. This is not to talk about a large number of undergraduate students who took up research and product building at other places. So this is a very happy occasion, but of course, as any technological institution, we have a lot of room to increase the number of women students. I think our undergraduate student gender ratio is 25% right now. The research students, at the masters and research students, it used to be slightly better, but we have to maintain, we have to work hard to ensure it remains so, because we need all kinds of people to build solutions for the entire world. So let's all take that mission forward. Today, we have, apart from all the demos that will start in an hour or so, we have sessions. The theme of today's talk, today's R&D Showcase is Sustainable Future. So you will have presentations from a couple of groups in IIIT which works who has some special work in that. And we will have other roundtables and breakout sessions in the afternoon. And most importantly, we have the fortune of having Martial Hebert a good friend of mine for the last 30 years, a co-computer vision researcher who is spending precious moments of last few minutes of ICCV conference submission deadline with us here in IIIT Hyderabad to enlighten all of us. That will happen a little later. So with these words, I welcome you all again to the R&D Showcase 2025. Have a great time. Enjoy this session here. Go around and see things and give tough time to the students asking questions so that they all get better. Thank you.
Thank you, Professor. Now I would like to invite our Dean of R&D, Professor C.V. Jawahar, to kindly address the gathering.
Welcome to this edition of R&D Showcase, which has a long history. The first one, which we had in 2001, where what we were demonstrating was the small projects done by the undergraduate students in their final year. The projects that they have done in 6 months, 1 year, small systems. To today, when we do this in 2025, we have projects which possibly continued for 10 year, 15 year in different forms, which graduated multiple PhD students and multiple theses that came out of it, funded by many industry, governmental institutions, etc. So you see a variety, the growth you can easily see from the type of exhibits, presentation that we have. We also have evolved from this, from a pure demonstrations of projects to a variety of activity focusing on different segments of the society. So we have today more of industry, academia, senior researchers from different places, while tomorrow we have more of students from various engineering colleges visiting. So the visitors are diverse and their interests are diverse. We also don't want to have crowds. So we are seeing interesting concerns which we have over the years. So for this year we had, Aftab asked this question once, saying that look, last year we had around 300 plus posters. How many we can allow? How many we can afford? And this is a question that we need to figure out, because if you have 300 plus demos or exhibits or posters in this building, it's a good problem to have, but it's a bad problem in the form of we don't have spaces. We are getting complaints from faculty members and students saying that, oh, no, we don't have spaces. And we are getting complaints from visitors saying that, okay, we cannot finish all of them in 3 hours or 5 hours or in a day. So we need to take a right balance between these two, but it's a good problem to have, and we should enjoy this, having the luxury of having more and more things to show. So we always believe that by demonstrating, by talking about what we do to external people, we learn a lot. We get feedbacks, we get criticisms, and far more, we learn how to explain the concept to different segments of the society and ask ourselves in what way this is relevant, this is connected to them. This sort of an event also builds a lot of interesting relationships. So every year after this, we had seen discussions that happened in the corridors leading to active collaborations between the groups and external entities, leading to sponsored projects. and long-lasting relationships. Now, last few years, we also have, in addition to it, roundtables. We have 3 roundtables today afternoon. Last few years, we have systematically brought the startups ecosystem on campus to come and demonstrate things along with this on the sidelines. This year, we have a special room dedicated to maybe socially relevant projects getting grouped into a new perspective, because we also don't want them to be lost in the middle of a lot of other posters and demos. So the evolution of this has been very, very exciting and enjoyable, and we are getting a lot of appreciation from people who visit, except their complaint that we are unable to finish all of them in few hours of time, and we are tired by the end of it. And faculty members complaining about like, oh, we are not getting the prime room. Students are complaining about we are not getting the prime room, we are not getting enough visitors. Remember, if there are 300 plus exhibits here, you need 300 plus visitors to engage you always. And the moment you have 300, 500 visitors, these corridors will be full, the rooms will be overflowing. So we have interesting puzzles to solve. Maybe we'll do far better when we move to the new buildings, this sort of exhibitions in a couple of years' time. Until then, we have to possibly live with this. Yeah. Please walk around, see the posters, see the exhibits, ask questions, learn about them. You may not know how other projects are done. Please ask and learn from them. If you are an external student, external researcher, please go and interact with them, ask difficult questions, and build bonds. And we hope this is good for everybody, and we all will enjoy this today and tomorrow. Welcome to R&D Showcase again. Thank you.
Thank you, Professor. We now invite Professor Marshall Eber, Dean and University Professor of Robotics, School of Computer Science at Carnegie Mellon University, to deliver his keynote talk on challenges toward the next generation of AI systems.
Good morning, everybody. I need to reset the computer here. So I figured I would try to fit in, so they gave me that T-shirt here, right? Let's see here. Okay. All right. Okay, well, good morning, everybody. It's a pleasure to be here. This is my first real trip to India. I've had a couple of trips earlier, but this is the first real one. And it's a pleasure, especially to be here in Hyderabad and to finally see what my friend PJ has been talking about for a long time. So that's wonderful. So what I'm going to do today is to give you a bit of an overview of some of the things that we do in the School of Computer Science at Carnegie Mellon University. And by the way, this is in one sense a technical overview, and in another sense an absolutely shameless advertising, okay? Especially for those of you students, you know, we open for the next round of applications, okay, if you're interested, okay. All right, so we have, just let me tell you a few words about the organization. I'm not going to talk about it too much, mostly about technical things, but just to set the stage. We have 7 departments in the school, even though they are, some of them are called institute, but they're actually academic departments. So we have, of course, everything that has to do with the fundamentals of computer science in the computer science department. But, you know, we take a very broad view of computer science that goes much further from what you would think as core computer science. So, for example, we have a department dedicated to human-computer interaction. The folks in that department are not what you would call core computer scientists. They are designers, social scientists, learning scientists, psychologists, etc. We have a machine learning department, the first of its kind, looking at all the fundamentals of machine learning theory, but also machine learning systems and application. Language technology, looking at everything that has to do with communication, speech, translation, documents, etc. And of course, nowadays, large language models and generative AI. And in fact, we just introduced the very first generative AI degree in that department. S3D is actually stands for Software and Societal Systems Department. We thought we would really try to stretch the capabilities of the university system by putting a digit in the department name. So it's called S3D. Some of you, maybe a few of you know the history of CMU. This is a department that used to be called ISR. I think somebody in the audience was at this department, is an alum from this department. Looking at everything that has to do with software engineering and related topics. The Robotics Institute, of course, that's where PJ was in an earlier life. You know, it may sound strange that we have a Robotics Institute under the School of Computer Science, right? Robotics is quite often thought of as on the mechanical engineering or some part of engineering. It's very important that we have it on the School of Computer Science because that gives us a much broader view of what we mean by robotics. We don't mean just the physical aspects of robotics, but the intelligence, the computer vision, AI, planning, autonomy, etc. And finally, our last department, our most recent department, which is called CB on the slide. Anybody has any guess what CB stands for? Computational biology, that's right. And this is again makes my point earlier, that a very important aspect of what we do is to take a very broad definition of what we mean by computer science, by AI, by robotics, and all this. So in computational biology, we look at using AI and machine learning ideas, and even robotics, to biology research. Single-cell genomics, precision medicine, cancer research, for example. Okay? And I'll mention that a little bit later. Okay, so that's the quick view of the school. Let me now go through a few of the big directions that we're going across all those departments, primarily in AI and machine learning. Okay? So for the first one, let me remind you of what has been responsible, the ideas that have been under the most recent transformation of AI through generative AI. And what has really had a massive effect is a very simple idea, which is the idea of learning by training a system that does basically a very simple task, which is predicting the next word, right? This is how large language models are trained, right? You hide a word in a sentence and you ask the system to predict what that word should be. All right, very simple. And then at runtime, you can then generate answers and sentences by predicting the next word. Now, underneath that, there is a very important observation, right? Underneath that, there is the observation that because I do the training this way, right, we can use completely unsupervised data. There is no need for any labeling, any supervision whatsoever. That's why it works, because then you can use nearly infinite amount of data, because there is no supervision. So the basic idea, under this transformation, independently of the details of being text and being words and all that, the fundamental idea is to be able to do training in a way that is very nimble in terms of supervision and annotation of the data. So that's for text. That's what we all know about large language model and generative AI. What we're trying to do across the board is to do this in all aspects of any discipline and application. So for example, this is an example here. This is from my colleague Deepak Pathak, assistant professor in robotics, where we're controlling a robot. Of course, the person doesn't see the robot here. We're controlling the robot by observing a person, right? There is no motion capture. There is no 3D. This is from a simple single video. Now, the way you could think of training a system to do this is to say, well, I have plenty of videos on YouTube, you know, of people doing stuff with their hands, right? So I could use that to train a system that will relate the hand motion in the video to the robot motion. But if you do that, naively, you're going to have to annotate all the videos, and you have to annotate it in a way that's very difficult, very expensive. It's simply not practical. You are never going to get the size of data that you need to learn effective models. The size of data, for example, that is used in large language models. So what they did is to figure out, and I'm not going to give you all the details here, okay, because that gets a little technical, but basically to figure out how to train the system without annotating the videos. You see, this is this idea of being nimble when it comes to data annotation. And now you can train the entire thing from raw YouTube video, in this case, thousands of videos without annotation. So that's applying those ideas that transform the AI to other domain, in this case, human interaction. And then you can show that you can use this for a variety of tasks. Those are some example of various tasks where you can do this. Okay? So this is one example of that nimble idea of being able to use as little supervision as possible. Okay, this is another example of this. This is from the work in my group. And this is basically the idea, this is a computer vision example this time, the idea of learning representation to do the kind of thing that you see here on the screen, which is basically segmentation of a scene. You have an input video, you want to segment it in this way. Now, you could do that by training, by labeling lots of video and doing supervised training. You would like to do this in a completely unsupervised fashion. You would like to have lots of video for training and in an unsupervised fashion be able to learn a model that will do that. Now, there were things in the literature that did that, things called slot representation, slot features, and they would work on this kind of example, right? Very simple example, right? Each color corresponds to a different block, so it works really well, but it's very simple. And of course, when you use it on real data, it does not work at all, right? This is completely wrong. Each color corresponds to a different segmented region, which is completely wrong. So what we did is to say, well, because it's a video, we have a little bit of supervision for free. So it's self-supervised, right? You have supervision that comes from the video itself in the form of motion extraction in the video, okay? And then if we do this, we get now a correct result, or a result that's close to what we really want. So again, that's this idea of going away completely from the old paradigm of having lots of annotated data and supervised data towards something that is completely self-supervised. Okay, the second big idea behind the revolution in AI, things like large language model, is this idea of having general model, right? A large language model is not a model for a specific task. It's a general model of how language works, okay? And then it can be applied to different tasks. So this is a very powerful idea, obviously, as we all know. But the question is, can we do this in other domains? Can we do this in other disciplines? And one of the big things that we're trying to do is to apply that idea to basically virtually every domain and every discipline. This is an example here. I shouldn't play this, but this is an example here from biology, where one could start thinking of using biology data, genome data, basically all the data that's available out there, including new experimental data, and use this to build a model. So this is the equivalent to biology of large language model for text. So that's something that is a big direction of research. Now, there are some interesting things that happen when you look at things like this. For example, hallucinations that are extremely annoying when you're dealing with text, right? Something you don't want. In the scientific case, hallucinations may be interesting because they may correspond to scientific hypotheses that you had not thought of. So this opens up new ways of doing scientific discovery that we're looking at. So that's one example. I give you this example because it's completely outside of the traditional computer science-ish kind of example. Another area where we could think of general models where we were never able to do that is in robotics, right? So if you look at robotics over the past 50, 60 years, right, the way it works is that we spend a lot of time coding algorithm or coding learning techniques, if they are not explicit algorithm, for specific tasks, for specific configuration mechanism, etc. But we could obviously go much further if we could somehow learn a model that is very general of how sensory input is mapped to action. And in fact, not to push the biological comparison too far, but in our body we have a sensory motor cortex, right? That basically is not a cognitive thing, right? When you move around, you have this general model in your body and your brain that will connect your sensory input to your body and adapt to whatever condition your body is in, just like a robot should adapt to how its actuator works and all this. So that's the idea of having a general model as opposed to special purpose model. And so this is again the work in Robotics Institute from Deepak Pathak. This is an example here. So this little robot here, first of all, it's a very cheap robot, right? So it's actually a very poor robot from a hardware standpoint, right? So whatever model is used here has to adapt to this. It has to learn and it has to adapt to this. Second, it has never seen this environment, has never seen, in fact, similar this particular environment. So it is trained on massive amount of data, simulated data, and then adapted on real data. And what that gives you is very powerful capabilities in terms of the task. You can see some of the tasks here that it does that are very hard to do in with special purpose code. And the ability to adapt to different capabilities. And in particular, very importantly, the ability to adapt to degradation in the hardware capability, something that we were never able to do before. And that opens the door to being able to use much, much cheaper hardware, much simpler hardware than what we used traditionally in robotics. Okay? So that's what we're trying to do in robotics. And as a matter of fact, this is just to show you how important of a topic that is. This kind of idea led to a startup by two of our robotics faculty called Skilled AI last year, and this startup has now is valued now at $4 billion after 1 year, and the reason is because of the importance of those ideas around having general models that can be used for many different mechanisms, many different tasks, as opposed to specialized development. Okay, so let me show you one last example of this this idea of general model, and this one comes from the work in my group. So this is again a computer vision example. You might have seen some of those kind of pictures on movies. Those are the kind of things that are generated from things called diffusion model. Okay, so diffusion models, the short explanation is that you get around the need for supervision by learning how to denoise images or video. Right? So you have lots of videos or lots of images. You input them with noise. You want to output them with no noise. And by doing this, you learn an internal representation that is very powerful. Now, the reason why you do that is because you do that on an enormous data set of unprecedented size. And because of that, you can learn a very general model. So this is this idea of generality again, just like for large language model, but this time for images and videos. So you've seen some of those systems. We didn't do those systems. Okay, those are Facebook and other company, OpenAI, etc., system. So this is out there. We have this, and this is used for generating images and videos. Okay. So the question that we try to, so this is again the idea, you add noise and learn how to remove noise. That's the basic idea of diffusion. So the basic question that we try to ask is, can we use that general model to also do computer vision tasks? It was designed originally to generate stuff, to generate videos, to generate movies or images. Can we use this internal model to do computer vision, to analyze videos? And we did two things. Now, this is the only place where I'm going to get just a little bit technical, but then we'll move on. We did two things. The first one is to say, well, let's keep that model and use that as features that we're going to use in an additional module. So let's say you want to do video segmentation. You can now use those features from the diffusion module in a segmentation module. Okay? So you basically add this green thing to the diffusion representation. And we showed, so this is where the general aspect comes into play. We showed that you can use this in a number of tasks, action recognition, object discovery, scene understanding, segmenting the scenes into objects. Label propagation, which is the one showing on the bottom right. Label propagation is basically, used to be called tracking, okay? You basically designate an object, a region, and then you maintain that object throughout the video, okay? So we did a lot of things here. In particular, we evaluated different features, different representation. The ones at the bottom are the what is called the video stable diffusion feature. This is the state of the art in diffusion representation for videos. And we showed that, so this is the kind of result that you get for label propagation. On the left is our result, right? This is using those general video diffusion representation. And on the right are using different types of features. And I don't know if you can see, because this is it possible to turn down those lights a little bit, maybe the front light, because we cannot see the screen very well. Yeah, okay, so if you can, yeah, I don't know if you can still see there, maybe not. Anyway, if you could see, you would see that you get a much better result. Let's see on this one. This one may be a little bit clearer. So this is an example on scene understanding and video segmentation. And again, the left column is using that diffusion model, state-of-the-art diffusion model for video. Now, it doesn't always work. If you look at the left video very carefully, you will see that dog is green. It's going to move in front of the red dog, and it's going to get confused. Watch carefully. See how it gets confused? Now we have a red-green dog. Somehow there's a piece of the dog that's left behind, okay? And on this one, if you look carefully, you can see that one arm of this person on the horse is going to get confused with the horse. If you watch carefully, right, it gets right there. Now, by the way, PJ and I go way back, decades. We don't want to admit how far in computer vision. Isn't it amazing that at this point we are preoccupied about whether a small piece of the arm gets mislabeled? Whereas back in our days, if we get one result on one image, we're really happy, okay? So lots of progress, people. Anyway, so the second idea that we looked at is to say, well, instead of keeping that general representation fixed, so what we do, we take that general representation known from, the Facebook model or the OpenAI model, right, and keep it fixed. So we said, well, maybe we can fine-tune it based on the downstream application. And there we get even better result. And in fact, we get better result in a way that we can do things that we could not do before. So this is a much harder task. This is called referring segmentation, okay? And the idea is you have an input video on the left, and you have an input text prompt, like in this case, the flame. And what you want to do is to produce as output this object, whatever is in the text prompt. extract it correctly from the video, as you can see on the right output. So this is a hard task, combining also text and videos. And we're able to show that because we have a very general model, and by the way, those diffusion features are learned on about 10 million videos. That's how big the data set is. We can fine-tune it on a few thousand videos to get performance on this task. And this is how it looks like. The left column here is our results. So the prompt on the first row is the pillar, which you see in the background here. And the prompt on the bottom row is the playground slide. You can see that it finds that correctly in our case, and it does not in the other cases. The reason why it does not in the other cases is because this is very, very hard, right? Those objects have a very small part of the field. It's a very small object. And in some cases, it's not even apparent in the entire video. Those are other examples that are historically very, very hard, because what the prompt is referring to, the smoke or the flame, are not object, with definite shape. They are stuff, changing shape, like smoke. And it's very hard. Most current computer vision application cannot deal with those examples. Other very hard example here. So in any case, the bottom line, I get maybe in a little bit too much detail here, but the bottom line is this. Again, there is this idea of building a very general model from as much data as we can. In this case, typically it is on the order of 10 million videos are used to learn those very large models. And then to use that for specific tasks, in this case, computer vision tasks. And my basic point is that we try to do this across the board for robotics, for biology, for many other disciplines. Okay, I won't show an example here, but I mentioned in passing that a lot of what we do is not about the system, the AI system, etc., but has to do with the human interaction, okay? Understanding human, understanding their behavior, their intention, etc. This is an example here, slightly older example from Chris Kitani's group, where you're going to see those lines here emanating. Those are prediction of the future behavior or future path of that pedestrian. It's going to restart in 1 second. Actually, I have to restart it. There we go. Okay, so this guy, pedestrian 18. So it's basically showing prediction of its most likely behavior in the future. Okay, this is a very hard problem because the behavior of this person depends on the behavior of the others, and the others depend on the behavior of that person. So it's a very exponential, very difficult exponential problem. So those are the kind of problems that we look at, understanding people behavior, understanding people interaction. Why is this particularly important today? Well, it's particularly important today because of this kind of thing. Now, this is a very basic screenshot of an interaction with ChatGPT. Nothing fancy, many of you have done this kind of thing. But the observation here is that AI has reached a point now where we have an unprecedented level of interaction. This is no longer a level of interaction where we provide input, we get output, and iterate in that fashion. There is actually a total integration between the user thinking and the user interaction and what the AI agent does. And so this opens up a completely new area of research. This is a picture from Heni Admoni's group in robotics, again, where the idea is to have bidirectional interaction between the user and the system, not just the user controlling the robot, but the robot actually interacting with the user, either asking for help, giving input, asking for clarification on intent, and iterating in those ways. So there's some deep technical issues that we have not yet fully looked at in that field. Okay, so I talked about the need for nimble system, general, human-centered. The other thing that we look at a lot is how to put systems together, right? Not just looking at individual components, like video segmentation for self-driving, for example, but looking at the entire system and how to integrate this entire system. So let me show you one quick example. And this is actually a competition. This is a very large challenge, a DARPA challenge in the US, called the Triage Challenge. And by the way, other institutions are invited to join that challenge. So if there are students here or faculty who are interested in participating, we can explore that. And the idea is this. Imagine that you have, this is a kind of a depressing picture, I know, but let me explain why it's there. Imagine that you have some kind of disaster area like this, an accident, a natural disaster, where you have a lot of potential people hurt. The way that is dealt with now is you have to send highly qualified medical personnel to do basically triage. You need to quickly assess who is in immediate need of help, who can wait, and prioritize the medical help that you give. What DARPA is trying to do is to fully automate this and to send robots with the appropriate sensors and the appropriate AI and machine learning tools to be able to assess the situation and do the prioritization of treatment. So this is a very large system that includes everything from the hardware, the robots, elaborate autonomy. They have to be mostly fully autonomous. Specialized sensing, new ways of sensing, so you can assess from a distance vital signs and things like this. All the AI and machine learning for analyzing this data and making decisions. So this is a pretty ambitious area, and again, I invite you to take a look at this. PJ might recognize some names there. To take a look at this if you want to participate in that, but this is just one of many, many examples of what we mean by engineered system. Okay, the last thing that I will mention, how much time do I have left? 2 minutes. Okay, all right. Okay, 2 minutes, okay. So the last thing that I will mention really fast is the idea of multidisciplinary research. And this is fundamental to everything we do. And it's the idea that to join the techniques that we develop in AI, machine learning, computing, etc., with all of the other disciplines. I mentioned already, this is an example here of our new AI Institute on societal decision making. And the basic idea is to use AI and machine learning tools to help make decisions in crisis situation, natural disaster, etc., etc. The important point here is that this institute is jointly between people in our machine learning department that do deep work in machine learning with people in humanities doing work in social decision science. And in fact, we're in the process of creating the very first PhD program in AI for societal decision making. I mentioned biology. I told you about this idea of using a general model for biology. We also, at the university, have what is called a cloud lab, which is an automated lab. So instead of standing in the lab doing experiments, you can send code to the lab, and it will execute the experiments automatically and send back data. So now you can not only have AI and machine learning process large amounts of data to generate hypotheses, but to also generate experiments, execute the experiments automatically on the automated lab, get back the data, and continue that loop. So we're doing this not just for biology, but also for chemistry, material science, etc. So we have a lot of other examples of this. Actually, I'm out of time, right? Okay, so I'll just mention one bit that I think is an extreme example of what I mean by cross-disciplinary work between AI, machine learning, and the sciences, okay? And I'll end with that one, I promise. And that has to do with nuclear fusion. As you know, nuclear fusion is the hope for free energy in the future, or at least clean energy in the future. It does not work yet. The reason why it does not work yet is because it's very difficult to control what is called plasma confinement, basically the process that is around nuclear fusion. It's a very difficult system. It's impossible to have explicit control. It's impossible to write equation to control it. So what do you do when you have a system that you cannot explicitly program, explicitly control? Well, of course, you use machine learning, right? That's what we do. So that's what we did. I'm not going to get into the details of that, but basically it uses a combination of reinforcement learning and other ideas to be able to better control the nuclear fusion system. For those of you who are into it, that's plasma confinement. And we're making great progress on this. This is an interesting picture. This is a picture of the control room at the San Diego tokamak. Tokamak is basically a huge nuclear fusion experimental reactor. All right? And this is their control room. And that person that you see there, it's the session leader. It's the person directing the entire experiment. I mean, it's a place as large as this building, right? And he's in charge of the entire experimental thing there. Now, the person sitting at this seat normally is a physicist or a fusion engineer or plasma engineer, that kind of thing. This is the very first time that it's not the case. This guy here is a PhD student in our machine learning program. It's the first time there is an AI engineer controlling the fusion experiment. So I thought this was a kind of a symbol of how far we're trying to go in fusing AI and machine learning with the sciences. Okay? And in the interest of time, I will stop here to basically conclude with those 5 big directions that we look at in the school, and leave you with this. Hopefully not too much over time. Okay? All right, thank you.
We can take 2 questions. We didn't want to end this without questions, so Professor is going to be around for a little bit after the session. So please do find Sir and talk to him, but we can take 2 questions. Who wants to go?
By the way, the one question I cannot answer is what is the status of my CMU application? I cannot answer that, okay? You just do. Huh? Yes, yes.
Hello.
Yes.
So when you do this kind of imitation learning or learning from videos,
Yeah.
so and especially for an arm which has a physics of its own, so how much of physics we can bypass by pure crunching? Because whatever we have seen is when we incorporate learning with some kind of physics information, like so for example, you don't directly learn the action space, but you learn parameters of a controller that would further you use it along with an optimization to learn action, rather than using directly action transformers and things like that, right? I mean, so how much of physics you can bypass, and do you think you can completely bypass Euler-Lagrange dynamics?
Yeah,
when you do that kind of
I don't know what the general answer really is, right? Because that's work in progress. But at least in some of those settings that I showed, you can go pretty far in bypassing explicit physics. Yes. In particular, that one example that showed, it's really truly direct mapping from the videos to the control. So in that case, at least we bypass that. Yeah.
Images or videos to action, it becomes very specific to some distribution, like especially self-driving or in manipulation as well. And so, when it goes to a certain other distribution, then and also there are no guarantees. Like for example, suppose I learn actions directly from perception. I cannot guarantee things like collision avoidance, and there is no way that we can have such guarantees. Which perhaps if you couple it to an optimization.
Oh yeah, no, of course, yes. So this is basically work to see, this type of work is to see how far we can go on the learning side, just looking at the learning side. Now, there's another part of the work that has to do with once you have this kind of capability, how do you make it characterizable, right? And having predictable performance and guarantees, like you said. So that's an added component to this. And we have work on this that I didn't talk about at all. That looks at that, and that looks at, in particular, in the context of safety and being able to give guarantees that need to be added to those things. As far as the out of distribution problem that you mentioned, that is a very fundamental problems in all of those approaches, and something that we look at separately in other research on this topic. But this is a fundamental problem in all of those approaches, meaning that we don't know very well how to characterize what it means to deviate from the universe of data on which it was learned, right? This is part actually of something that we look at in a new institute that we have on AI safety, and some of the things that they look at have to do with this, how to characterize those ML-based systems.
Thank you, sir. I said two, but we'll do one more quick question. Yeah.
Talking about AI safety, isn't nuclear fusion the last thing that we should be doing? Because even if it is 99.999% accurate, so there's still a chance, unpredictable chance that something will go wrong.
Yeah, well, it's fusion, right? Not fission. So the level of the types of risks are completely different. Just to be clear. So, and yes, of course. I mean, it's kind of the similar answer to that question. There's two lines of work, right? There's one line of work that says I'm going to look at how far I can go with those kind of techniques, right? Perhaps that's going to allow me to address some problems that could not be addressed before, like in this case, getting a level of consistency on the control that could never be achieved before. So that's one line of work that needs to be done, right? We can explore it. Then the other line of work is, given that, how we can now develop tools that can characterize, say, performance, stabilities, guarantees, etc., right? Even though you may not have formal guarantees in the mathematical sense of, say, an explicit controller, for example, right? You can still get guarantees in terms of characterization of the behavior of the learning architecture, right? So those are the kind of things that we are looking at. Yeah.
We have a startup here that's in the nuclear fusion space, sir. It's come out of the defense organization. They work out of our incubator.
Yeah.
They have a tiny fusion device that generates 200 watts power, just instant. A fusion startup that's here.
Yeah. Okay.
So last question goes to the students. Please, anybody raise your arm, raise your hands. One student question. PJ insisted there has to be a student question.
Sir, you talked about this video analytics, nuclear things. I just like to know whether you are using the quantum computing for your work or just the simple GPUs.
No, we use GPUs.
Okay, that's students. Yes.
Thank you. So you talked about using self-supervised learning, and that allows you to use vast data sources that are at an unprecedented scale compared to before, right? And that would require an unprecedented amount of computation and resources. And seeing how our own R&D Showcase has this theme of tech for sustainable futures, how far are you thinking about sustainability and where does that play?
Yeah, so there is, obviously I'm showing you here a small part of what we do in the school. So there's another part of what we do in the school. In particular, I invite you to take a look at it, something called the Catalyst group, which is a sub-part of the school that looks at machine learning systems and in particular at optimizing and reducing the footprint of machine learning systems. So that's part of your answer. This is another key research direction and research topic that we have. I did not mention it in this talk because could not mention everything, but absolutely, that is essential. In fact, my personal belief is that the idea that we're going to continue to make progress by exponentially increasing the budget of computing and data does not make, eventually it's going to break down, right? I mean, it's not scalable. So this is very important, that personal opinion, and I'm very hopeful because there is such a need to do that, obviously. I'm very hopeful that we're going to come up with a completely novel way of designing those architectures and novel ways to optimize them after the fact as well. I will finish by mentioning a new faculty member, assistant professor in the school, Albert Gu, who has developed a new architecture which totally outperforms the classical transformers-like architecture that is far more efficient. Now, it doesn't solve your problem completely, right? It still needs computing, obviously, but it goes in a direction, in a hopeful direction of having much more efficient architecture. Yeah. So yes, this is an essential topic as well.
So we've gone past time, but one last question from a girl student, being Women's Day, and PJ talked so much about like how well our girl students are doing and that we'd like to have more women students come in. So any of the girls, please, last question. You have the last word today. Anybody, please, or faculty also, but.
So if we have general ML or AI solved for like language, vision, and all the other senses that a human uses, what do you envision might be the biggest problem in the next 30 to 50 years?
Well, that's what some of the questions hinted at. The biggest, look, in classical engineering, right, the basic thing that one does in classical engineering, and the reason why we have all kinds of things that work, right, from elevator to car to whatever, right, is that we can take a system, including a complex system, and ask the question, if it operates within those conditions, if the input conditions are within those boundaries, then the system will behave within this envelope. That's the fundamental thing that we do in classical engineering. And for that, we have 200 years of engineering science behind it, from formal mathematical techniques all the way to best practices in engineering testing. We have pretty much none of that in AI and machine learning. Okay, this was referring to some of the things we discussed earlier, including the out of training distribution and that kind of thing. So that's where we need to go. In other words, we're going to continue to make enormous progress on the capabilities. We need to make progress on the efficiency, as was pointed out, in terms of power, energy requirement. And we need to make progress on this kind of engineering science for AI and machine learning. So we can actually have some handle on how we characterize those systems to deploy them. Right?
Thank you so much, sir. So I'll hand it back to the students now.
Thank you, Professor. I would like to invite Professor P.J. Narayan to felicitate Professor Marshall away with a token of appreciation.
Oh, I see. That's what you're going to do.
Thank you, Professor. As a part of R&D Showcase, each year we celebrate the research from Spotlight Centers. This year the theme is Tech for Sustainable Future. So the Spotlight Centers are Software Engineering Research Center, SERC, and the Cognitive Science Group, CSG. I would now like to invite the center heads from each center to come up and speak about their work at their centers. First up, I would like to invite Professor Raghu Reddy to come on stage and give us an overview of SERC.
Good morning. So, great talk. And of course, interesting questions, and that's precisely what we are trying to get to, is, you know, get to the engineering side of it as part of the Software Engineering Research Center. So one of the areas that we probably look at, because we've been hearing about AI for bio, AI for X. So what we try to do is look at SE for AI, right? So how do you actually try and look at engineering AI systems and AI components that are probably critical, right? So how do you look at some of these problems are one of the focus areas within SERC. So let me just use a clicker, and since we are on a time crunch, as I'm informed, so I'm going to quickly skip through some of the slides, just focus on a few projects that we're doing. Obviously, there enough number of demos if we go to the, you know, first and second floor, and one of those rooms obviously has a lot of displays from Software Engineering Research Center. Okay, so broadly these are the areas that we work on. In terms of areas of research or sub areas within software engineering and allied, so if you really want to categorize, we look at some emerging technologies like VR, AR, IoT, but it's always in the context of what do you do with respect to software engineering and VR, AR, software engineering and IoT. So it's about engineering systems, building systems, and what do you look at in terms of best practices in the context of these, right? And as I said, SE and ML, the interplay between SE and ML, and the focus area for today that we're talking about, sustainability. So that's definitely one of the areas that we work on, where we start looking at how do you build sustainable systems, right? Especially in the modern context where models are getting larger and larger, and your computation is going to just, you know, boomerang in some sense. So how do you start thinking about systems that use these resources more efficiently, and what are the techniques, what are the methods? So that's one of the areas. So what sort of technology should you build, and what sort of AI models probably are better suitable under certain conditions, etc. So I'll give you just quickly some glimpses of some of the work that's currently going on. And one of the largest things that earlier Jawahar was pointing out was this multi-year project that we've been carrying out, and this is a very, very large initiative from the education perspective, right? So Virtual Labs project that's been going on for at least, if I'm not wrong, nearly 13, 14 years when we actually started it. This is a multi-year effort, and it's a consortium effort spanning about 11 institutions across India. And IIITH has been playing a major role since the start, and off late, because we've pretty much maintained the entire labs in some sense, right? So the entire engineering effort for hosting and continuous updation is done right out of IIITH. And this caters to, as far as I can remember, of course these numbers are a little old, probably 80 million users. So from across the world, and not just India. So at least 15% of the users are from outside India. So these are labs meant to supplement engineering, courses across tier 2, tier 3 institutes across India. And so as a result, it also gets used by countries outside India. Many labs, so that's the link. So please feel free to go have a look. As I said, I'll probably skip through some of the slides with projects, so and just focus on some projects for now, given the lack of time. So one project that we are right now trying to do is look at how do you think about models and model switching on edge, right? So given that most of the processing now probably you're looking at with your laptops or your mobile phones. So dynamically, can you actually switch your models? And how do you get computation in terms of the amount of energy maybe that's probably consumed, or when you run this model, can we actually measure it? And that way you're able to make a decision as to which is the more optimal model for a specific problem that you're trying to solve, right? So these are some projects that are running. So this is something that we've been able to show as part of Qualcomm Day. 14 other institutes from across the world were chosen. Very happy that IIITH was one of the 14 institutes from across the world, right? Another that is relatively new is this idea of autonomous cloud ops. So we've kind of built a co-pilot called Marvin, which actually helps you to make a decision about resource consumption, resource utilization, etc. on the cloud. So this is done with a startup called Monte Cloud. This is another effort that's with respect to sustainability, where we are working with Lloyd's Banking Tech in terms of how do you adapt your particular environment, right? So this project is all about self-adaptation and using MAPK loops with respect to energy measurement, etc. Yeah, low code, that's the buzzword, right? And certification. So this is kind of an answer to one of the things that we're trying. How do you actually certify systems which probably have AI components in it? So nowadays, a lot of defense organizations are kind of, it's coming from a top-down effort where you're trying to integrate AI components into critical systems like missile systems, etc. Right? So which probably have to be very, as Vikram was saying, 99.999 and probably go on. So how do you certify such systems? So what sort of frameworks are possible? So that's one of the efforts that's going on. As I said, another area is SE plus, applied domain. So one applied domain that we have quite a few projects running are in virtual reality and augmented reality. So we're trying to build SE for virtual reality systems. So you have a very systematic approach towards building VR applications, right? Which generally are done a little bit more from a gaming perspective rather than an actual enterprise VR perspective, right? So we're trying to build a model-driven way of doing these things. Some applications that we have built as a result of this VR research, where we are trying to build our own headset. We have tried to build some depression-related mats. We've kind of got some patents for locomotion in terms of infinite locomotion in a finite space, etc. And again, all these projects are probably going to be out there. Some other efforts with respect to the same, trying to use VR for understanding physical fitness. This is a part of the project with Meta, and wearable gloves in terms of haptics with respect to healthcare, some related work that we're doing where you would be able to use wearable components and conduct experiments. This is a relatively recent project to encourage adoption of GitHub Copilot within the banking industry. Another EA project about user-generated content. Yeah, so this, as I said, broadly speaking, there are many areas, but fundamentally it's all about engineering systems, engineering good systems. What are those specific qualities that we try to look at with AI or without AI, right? So of course now, it's generative AI. So generative AI for SE, SE for generative AI. That's broadly the areas that we look at, and there are obviously applied domains in that context. So the faculty list is here, and thanks to all the collaborators and the funding bodies that have funded us over the years. All right, so please visit H204. So that's our sales pitch. Thank you.
Thank you so much, Professor, for that. Sincere apologies. CSG is the Computer Systems Group. With that being said, we would now like to invite Professor Suresh Purini, Center Head of the Computer Systems Group, to give us an overview of the research and the initiatives at the center.
Check. Okay, namaste and good morning, everyone. So my name is Suresh Purini. So I am part of Computer Systems Group. To get started with, so this is, I want to briefly kind of bring out the vision statement for our group. So what we would like to do is, we would like to drive research and innovation in computing systems ranging from edge to cloud by exploring key areas across both hardware and software, including areas such as architecture, compilers, programming languages, networking, distributed systems, IoT, security, so on and so forth. By using AAML for systems and also build systems for AAML to enhance scalability, performance, and energy efficiency in emerging computing systems. So you can see that it is a bit of a very broad, quite a bit of mouthful of areas. But as you see that the kind of projects that we have been doing in our research center indeed cut across all these areas that you see in this our vision statement. So yeah, the team. So I am Suresh, and then along with me, Dr. Deepak Gangadharan is there, and Dr. Tejas, and we have a couple of more faculty joining our CSG center in this month. So we will become a strong group of 5 faculty, and we have around 25 students, including PhD, MS, and undergraduate students. To kind of highlight what we are doing, so we'll just go through some sample projects and try to get a feel for the kind of work that we do in our research center. Yeah, so before that, just want to kind of let you know that there is, in the afternoon from the CSG group, we are leading a roundtable industry academia conference at 2 p.m. in faculty meeting room in KCA's building on AAML on the Edge. Please do join that. To get started with, so we built a very interesting DSL compiler and an associated hardware accelerator. So some of you might be knowing, like there is this famous domain-specific language called as Halide, which works for using which we can easily express programs coming from the image processing space. And once we express programs using this domain-specific language, there is a lot of structure the compiler can understand, and we can easily target these programs for optimizing energy efficiency, performance, etc. on a variety of hardwares. So from IIIT, we have our own Scala-based domain-specific language called as Flopix, and we have a compiler. What it does is it takes this Flopix DSL program and then generates kind of an intermediate representation, and using this intermediate representation we can configure an overlay architecture which is built on a overlay hardware accelerator which can run on an FPGA. And then we have another project in this space. So as you know, like these deep learning models, they keep evolving. They are evolving at a very rapid pace, and there is a learning part to it, and then there's a training part to it, and then there's an inference part. And as much as energy efficiency and all kinds of stuff are really required for the training part, even in the inference also is very important, because if you would like to deploy deep learning model on your mobile phone, it needs to run fast and energy efficient at the same time. So we have in this space we have built a but then if you kind of build any kind of ASIC to expedite the computations of these deep learning models, what happens is by the time you this ASIC comes out, we move to the next generation of models. So we are always catching up. Models are a moving target. But then if you use FPGAs, what happens is it is possible for us to kind of evolve our hardware also at the same speed. So here we have built a very extremely good hardware accelerator which can kind of process any of the famous CNN vision models that you can that you would have come across. And I would like to say, so there's a lot of complexity in building these models. The previous the hardware accelerator for image processing programs and the hardware accelerator for CNNs, these are extremely complex. Like it takes at least 10,000 to 20,000 lines of blue spec code, and if you translate it to regular Verilog or RTL code, it will come to around 50 to 60,000 of code. So we build such complex systems in our lab, and this we have a lot of experience in building such hardware accelerators for a variety of domains. And based on this experience, so what we are trying to do is we are trying to see, hey, can we automatically synthesize these accelerators from the scratch, instead of writing tens of thousands of RTL code, which really takes around a year to 2 years of time. Can we use the latest LLM based models and then see how to build, synthesize these accelerators automatically. And of course, this equally holds good in the context of regular programs, that with software development also. But one fundamental question that we are trying to ask in this space is, so far we have been writing programs in C, C++, Verilog, etc. And then suddenly we want to move all the way to the other space and say, hey, we want to write programs using natural languages. It's like going from one extreme to the another extreme. And the question that we would like to ask is there any middle ground, okay, which is not too low level like Verilog, or it's not too high level like natural languages. So this is the AutoArc project. This is a work in progress, and we are seeing good results. So we also work in high performance computing space. So we all of us know, at least people who are working in computational biology know there are a whole bunch of problems, sequence alignment problems, which are super computationally expensive. And we are trying to build special purpose hardware accelerators for these sequence alignment algorithms, and trying to see how we can integrate these accelerators into this RISC-V SoC based ecosystem. And also we are trying to come up with algorithms to how we can run these sequence alignment algorithms on NPUs and some other devices which are specifically built for accelerating machine learning workloads. So we would like to reuse these accelerators which are built for ML workloads to see how we can use them to expedite computations that are coming from the genomic applications space. Yeah, again, so there is a compiler building effort that is going on, where we are trying to see how we can translate Halide DSL programs into this into a form which can be executed on these neural processing sticks. So moving from architecture to high performance computing to distributed computing, so we have lot of work that is happening in distributed computing and distributed ML, so to speak. So let's assume in the city of Hyderabad we have 50,000 cameras, and so 50,000 CCTV cameras. So there are 50,000 CCTV camera streams which are coming at high speed, and we really would like to, but if you want to ask any question, if you want to get any relevant information from these 50,000 camera streams, it's going to be super computational expensive. So we have a very interesting project in which we do a little bit of pre-processing, but we will be able to answer real-time queries from any of these, from the information that is captured in any of these 50,000 camera streams that are coming into the data center. And moving on, so we are doing some good amount of work on building low-cost digital twins, specifically targeting the traffic space, traffic engineering space. So instead of the fundamental question that we ask is, if you want to build a traffic digital twin, so maybe you may want to keep 50,000 cameras or 1 lakh sensors, things like that. But can we but it is very expensive to maintain the traffic digital twin. So the question that we would like to ask is, can we use the spatiotemporal relations in the maps to kind of optimize the placement of sensors, so that we can so that the cost of maintaining the digital twin is very manageable. Also here, it's just not enough to have a digital twin. If you want to elicit some interesting information from it, so we should be able to interact with the digital twin. So we are working on natural language mechanisms to interact with the digital twin that we are building and maintaining. So there is work where we are doing on core Linux kernels. So like, for example, if you have a computer with 8 cores, so there is a lot of compute available, but the problem is the memory bandwidth that is there, is limited, so you will not be able to provide sufficient amount of data to all the 8 cores. But it could be the case that some cores really require more memory bandwidth, because the programs running on those cores, they have low compute operational intensity. So we are building, kind of modifying the Linux kernel to see how we can manipulate this, modify this memory management unit in the Linux kernel, so that it can allocate memory bandwidth to cores which really need it. So this is in the Linux kernel and operating system space. So we are also working on security aspects of UAVs, and also scheduling algorithms on operating systems which run on UAVs. So we have one faculty, Tejas, who works in stochastic optimization and performance modeling. So I will not get into the work that he is doing, but overall what he does is he uses the ideas from the optimization tools and performance modeling tools to understand the performance aspects of computing systems and how we can analytically model them and get better performance out of it. To kind of conclude this last thing, there you can see the picture here. All of us know, like when we are training LLMs or any of the machine learning models, training time is quite large. So, so an interesting problem which Dr. Tejas works is if you take the objective function, you can see there is it can have one particular kind of surface. If we can do some kind of manipulation and change the surface into some kind of a steeper surface, so and when we do a gradient descent search algorithm, so whenever we take a step, we will be converging much more to the optimal performance point. So this is the way, like this is how we use optimization tools, convex optimization and other reinforcement learning and other kinds of tools to solve problems from the systems by using these tools. I think this is the kind of overview. What I would like to impress upon all of you is, there's a whole bunch of things that we are trying to do, from computer architecture to compilers to operating system level stuff, to using mathematical tools to solve problems arising from in the computing system space. And I would like to take this opportunity to thank our director, dean, colleagues, and all of you, all the students of IIIT community, to make this journey possible. Otherwise, it wouldn't be so much fun and great. Thank you.
Thank you, Professor. So that was the 2 spotlight centers for this year's R&D Showcase. Now we move on to the panel discussion on net zero software. To join us for the discussion, we have Mr. Naveen Balani, Global Managing Director and Chief Technologist at Accenture, Mr. Srinivas Raghunathan, a Senior Program Manager at Microsoft, and Professor Sridhar, who is also a IIIT alumni, the Associate Professor and Head of CSE Department at IIT Tirupati. The panel will be moderated by Professor Karthik Vaidyanathan from the Software Engineering Research Center.
Okay, so yeah, a very good morning one and all. Super excited to be doing this. First of all, thanks to the R&D Showcase team for arranging this panel and for selecting this theme. Welcome to all the panelists as well. I'll go one by one in some time. But before that, I would like to start with something, right? So if you look at it, this year's theme of R&D Showcase is Tech for Sustainable Futures. And if you look at tech, we can know that, okay, today we are using technology for improving sustainability, for example, through smart cities, or you might come up with softwares that monitor the ESG footprint of organizations, so on and so forth. But the most important question that often gets underlooked is this question about what about the sustainability of the tech itself, right? What about the carbon footprint of the softwares themselves, right? So there was a very good question that was asked post the keynote, and even Professor Marshall was mentioning about coming up with clean energy, right? Because the softwares are consuming tremendous amount of energy. 2019 report estimated that Netflix alone consumes energy that could power 45,000 households in the US, right? Just Netflix software. So can we say that, okay, stop streaming in Netflix to contribute to the environment? We won't be happy about that, right? And the other stat that came up very recently was that the total footprint, the carbon footprint of software is equivalent to the carbon footprint of air, rail, and shipping combined. And that's a very huge number. So the question then we keep asking is, what can we do from a software side or from a system side to make technology more greener, right? So that will be the theme of the panel. And with the ever-increasing evolution of AI, more and more computing gets added, this question needs to be asked. There is a lot of challenges in front of us. So we'll try to address the questions like what is green software, what are the big challenges in adoption, how can we create awareness, so on and so forth. And we have some of the wonderful minds in sustainability from the country here along with us. So thank you, all of you, for joining. Without any further ado, let me start with Naveen. Yeah. So Naveen, you are one of the leading voices in sustainability. For those who don't know, Naveen also has a very nice YouTube channel where he posts videos about sustainability, about LLM agents, and so on and so forth. I mean, this goes very contradictory as well, right? So we'll come to that. So Naveen does a lot of things like that, and he is also one of the co-founding member of the Green Software Foundation, which is a non-profit organization that comes up with practices for green software, that says to organizations how you can make your software more greener and so on and so forth. So Naveen, just to set the context for the audience here as well, when you say green software, right, what do you mean by green software? What was the motivation for starting something like Green Software Foundation? Yeah.
Yeah, thank you, Karthik. First of all, good morning, everyone. So when you talk about green software, it is all about how do you design and develop applications with energy efficiency in mind so that you could reduce carbon impact. And when we talk about green software, we have to look at the space holistically, right from the software development life cycle. For instance, how do you embed energy efficiency and reduce carbon as part of your software development life cycle process? Be it using the right level of programming language, right level of architecture. Just to give you an insight, there was a recent blog I read where an organization moved from JavaScript to Rust. Rust is probably the second and third best programming language. And they were able to optimize the application by 60 to 70%, both in CPU and memory. And the most interesting part of this equation was it was only a small part that they migrated. So you didn't need to look at changing the entire code base, but only a small impact at scale can have a significant improvement both in terms of energy carbon, as well as for the organization, it's also mean a lot of cost savings. The other area that we look in when you talk about green software is the whole data initiative, right? Organization have been keep piling the data over the years with the intent that it might be used in future. And personally also is true, right? We all take selfies, photo, because our phone has infinite storage. We never go back and delete it. And all the information goes back to the cloud and so on. So from a data perspective, when you talk about green software, how do you bring in the whole green data aspects? For instance, how do you do optimized storage, backups, and so on? And then we have the AI angle to it, right? We talked about the classical AI and generative AI, right? And there was an interesting question in terms of if you have infinite, do you need to do infinite training because GPUs might be limited? The solution to that is using green AI principles. And few examples have come out in the last couple of months itself, right? With the DeepSeek model on how they can do intelligent training, use a different architecture as compared to transformer, and also reduce the training time and make it cost efficient. A couple of days back, Alibaba released their model, right? Which is even more optimized. It's a 32 billion model, which does the same capability with reduced cost as well as carbon efficiency. And finally, you have the deployment angle, which when you're deploying everything to cloud, the cloud runs on renewable energy. From a renewable aspect, which applications needs to run at what point of time. The concept that we call is carbon aware computing. How do you leverage carbon aware computing to reduce your carbon workloads? And finally, you have the infrastructure angle, because whether it's servers, GPUs, ideally you want to minimize that so that you could increase the lifespan of the devices. And also you need to look at it in total all of these aspects. So green software basically looks at all of these aspects, right from hardware, software, and how can you bring down the energy, carbon emission and increase the energy efficiency. And when we launched the Green Software Foundation almost 4 years back in 2021, we have 4 broad challenges when we started this. One is there was lack of standards and what it means to measure carbon emission. And that's why we started working on a specification called software carbon intensity. And last year we achieved the ISO specification also. Now, so any organization can now measure carbon emission in a standardized way. The second challenge we looked into it was around tools and technology, right? Now we have the standards, what tools we need to provide it to our developer community. And that's where we launch tools like Carbon SDK and the impact framework, which can help you measure and reduce your carbon emissions. And then we have the awareness and education angle, right? How do we educate our workforce, where we launch various learning materials, as well as there's a free course available through our Linux Foundation on green software. I encourage everyone you to take the course and be aware of the green software principles. And fourth one was basically around whole policy, right? How do we engage with organizations and universities and so on to make this further. So that's how I would sum it up, right? In terms of making green software, right, as a priority, as a first-class citizen, right, whenever you design and develop applications.
Great, thank you, and thanks for that holistic view. I think you took it from the basic hardware up to the cloud, and even the optimizing data storage, which is very interesting. I'll come back to that. And by the way, it might happen that IIIT will also be part of Green Software Foundation. There is a lot of discussion that is going on. So thanks to also Naveen for leading some of those discussion. So Sridhar, I mean, Naveen was mentioning something very interesting. I feel that you would, kind of latch onto it, which is about this measuring carbon footprint, right? And if you remember, we have been having discussions about, there are a lot of challenges in that space there. So maybe some of the people also, they don't know, right? What do you mean by when you say that measure carbon footprint of a software? Right? Where are we with that? How can we do that? What are your thoughts?
I think, yes, while there is a lot of discussion on green software, like we should do sustainability and stuff, right? The real question is, can you actually measure it at the first place? Are there metrics where you can measure? For example, if you say, I have an algorithm, okay, I have complexity measure, I have time complexity, I have different kind of things, right? Which are very, specific and concrete. Now, when it comes to measuring energy consumption, right, and of course, like, carbon emissions later, the way I think, at least like, in this space, has been like, again, the software has to rely on the underlying hardware, right? And the challenge goes like, do you actually get the values from the hardware, or do you just ask in terms of, okay, what is the CPU, what is the GPU, right? What is the networking? What are the various components? So I think one of the typical ways to measure energy consumption is to rely on these tools. For example, there is a tool called RAPL from Intel, which gives you the values of the energy, right? And like, there are many other tools like PS Utils and many tools. But when you say like, okay, it's the challenge here is, if you say that I want to measure energy consumption of a particular component, there are many other software that are also running, when you have the system. So is it like, okay, do you gonna pause all of them and then do measure? So one strategy that, that is kind of like being followed, right, in general, like we have also been doing, is to say that, okay, we're gonna run these experiments, measure not the direct energy consumption, but the patterns. So there is a task. So for example, there's a software, and this software, when it is being measured, now you measure it like, let's say, 10 times, you shuffle the task. So you look at the entire software as a set of tasks to be done, right? And measure these tasks over a period of time and with varied settings. So this way, at least you get a pattern of the energy consumption, not necessarily the actual energy consumption. This is where the challenge goes. Now from here, just one, we've been doing some experiments in our lab at IIT Tirupati on this. So one of the things that we asked was, because developers, like, software engineers or ML engineers use frameworks. So if I use, let's say, PyTorch versus TensorFlow, does it make a difference when I actually, develop the software from an energy perspective, right? It's not just about the program, but like, what are the tools that you use? What are the programming languages that you use? So all of these factors, again, have to be controlled if you want to understand the energy consumption. And it's not that easy, right? So I'm going to pause by saying that if you just move from this energy consumption from the software side, right? again, we have the SEI, now, ISO standard, right? There's also AI energy score, which is recently released. So one of the challenges with these scores is, of course, standards have to be generic. Maybe I'll talk about standards a bit later, but they have to be generic, but the way right now they are positioned is like too generic that it is very hard. So for example, like, the SEI index essentially says like, okay, you need to define units, right? And then calculate the energy. Now, how you define the units is left to the organization, is left to the software vendor. Now, this is where it becomes really challenging to kind of like, standardize and go, right? On one side, we are seeing metrics which are close to the software and hardware. On the other side, from an organization perspective.
Got it.
So I think these are the spaces where like there's a lot of things that could be done.
Yeah, it's also interesting because there are a lot of research students here, and I hope they also pick on some of the challenges that you're mentioning. For people who don't know, Sridhar is our alumni from IIT Hyderabad, and especially alumni of Software Engineering Research Center, so we are also very happy about that, Sridhar. Thank you. So just, extending what Sridhar was mentioning, Srini, I mean, so by the way, Srini is a PGSSP. He has a PGSSP student status with IIT Hyderabad. So Srini, you have been working with Green Software Foundation as well as you are part of Microsoft Sustainability Group inside Microsoft as well. You have written nice blogs from Microsoft as your standpoint as well. So I want to ask you this part, right? So he was mentioning about this challenge of metrics, not having standardized metrics, so on and so forth. Whereas you have been working on SEI, right? You have been one of the contributors of SEI alongside Naveen. So what is, from your perspective, when you look at software carbon intensity, do you say that it is more universal in nature? Like, how did you come about with that? And how is it getting adopted as well?
Sure. Karthik, thanks for asking the question. Sorry. From an SEI perspective, the whole premise is you want a way that is standardized, and you want a way that can, if you want to compare apple to apple, you have an Android application running somewhere, you have an Apple application running somewhere, you have an enterprise application. You want a way to compare and contrast so that you can make measurable decisions. All of you write software. All of you write software day in and day out. If we tell you, can you make your software run faster? Can you make your Python or Flask application run faster? You know how to do it. But do you know, if I ask you, can you make it more sustainable? Can you do that? And that's where this point is coming, to have a metric. Having said that you have an SCI metric, I think from my perspective, and this is a pitch for software engineering in a way, that while there is a metric and someone is there building regulations, someone is there trying to come up with metrics, I think as software engineers, it's in our own best interest to build software that uses less of electricity on your laptop, less of the hardware that is running on your laptop, and less of the electricity bringing in from the grid. So for me, a metric is a way, but not the journey. A journey will be how you write your code more efficiently, use memory more efficiently. Software was also written 20 years back when you didn't have 64 GB hard disks or 64 GB memory. We didn't have Azure at that time. We didn't have AWS at that time. So it still ran. You still had mainframes running then. So the way I look at it is, how do you build architecture? How do you design your software? How do you build it in a way that you use less of everything, more of garbage collection, more of memory consumption optimization, less electricity, such that it becomes, at a point when you are able to have these enablers coming from the industry or the academia, that you have these tools or standards, your software will already be conformant to those standards. I think that's the way I look at it.
Yeah, okay, and this, you want to add something there?
Yeah, so just wanted to pitch in, like, so I think we did, like, so Python is, again, like, used extensively, right? Not just for generic, even in AI, like. So one of the questions that we asked was like, okay, there is this programming language called R, right? And which also seems to be, could be useful for, data science, right? And they have a lot of packages and stuff, right? So the question that we asked was like, can we actually, like, do experiments to figure out if if data science or AI pipelines are built using our programming language, would it make sense from an energy perspective? Now, when we ask this question, like, we realize that, okay, there is a way to at least, measure energy consumption from software for Python, but there's nothing for R. So that's when, we built a tool called RJoules, right, similar to PyJoules. And when we ran the experiments, like, the results have actually demonstrated, at least, in the context of the data set, which is like in the orders of hundreds, thousands, and hundreds of thousands, that R is way more energy efficient in several contexts. So I think this is where I strongly believe that unless we have metrics and also tools to support those metrics and eventually get to the processes, if we can demonstrate that, then yes, probably software engineers and the AI engineers may look at alternate choices. Let's say, like, is there something other than Python that we can use for AI ML pipelines, right?
Oh, that's a very interesting point, because I had something in mind related to this. Because on one side, we are talking about the fact that there is no standardized metrics. One way to look at it is everything relative, right? Okay, with this metric, I'm looking at 10 as the consumption. Maybe with the same metric, will I get 12 or will I get 9, when I program or change my design, right? So you both touched upon this efficiency, right? But so I want to play a little bit of devil's advocate here, because it's a panel discussion, so why not, right? So you say efficiency on one side, right? Efficiency is a very nice way of saying, okay, let me improve the efficiency of my program so that it will probably consume less carbon footprint. But there is this kind of Jevons paradox that comes in, right? So if I keep reducing my efficiency, on the other side, I'm going to increase the consumption, right? For example, I create efficient cloud infrastructure, more people are going to use cloud. I come up with efficient AI models today, more people are using AI models because they are more efficient and people are using it. So when you look at this, these are a little contradictory, right? On one side, you are trying to improve efficiency. On the other side, consumption is increasing, which is also increasing the carbon footprint. So from an industry standpoint, I mean, Naveen, anyone of you can take this. It's how you look at this kind of paradox. So what I'm essentially trying to ask is, do we need some kind of systematic changes, which is not just looking at efficiency, but maybe more from a architecture level or design level, rather than looking at maybe optimizing for efficiency?
I'll try an answer. But good point. Like, as you start optimizing the resources that you use, your consumption goes for a toss. Your consumption increases. You can really see from how Copilot has evolved in the last 1 year. Exactly. People are now using Copilot for everything, whether it is relevant or not.
Yes.
You want to create a project document, rather than putting your brains to use, you go and use a Copilot. I think this is the way where, like you touched upon it a little bit, efficient and optimal use of the workload is going to come into play here. While you can't restrict businesses from asking for more. That is how the world has grown over the last 20 years or 30 years. That is how OpenAI has released what they have released. You can't ask people to stop consuming resources. But what you can do is focus on the core concepts of making sure that while you scale, you also talk about things like optimal use of hardware. Why don't you try, rather than setting up separate hardware for each of the workloads, can you do more dense utilization of your hardware? Right? That's where microservices come into play, right? You try to, I know from my product experience, when we deploy software, when my customer looks at my utilization and it goes above 40%, they become jittery. They say, no, set up more infrastructure so that it gets divided. But that is not the way it looks like. You make sure that you provide the same amount of SLAs, same amount of performance, even if your utilization goes to 80% or 90%. Now, that means you write efficient code and efficient algorithms such that you are able to provide the same amount of performance and latency for in spite of consumption increasing.
So essentially what you're trying to say is keep the utilization higher instead of distributing it into multiple
That's
compute
one
nodes.
strategy, yes.
Yeah, definitely. So, I mean, I want to come to you, Naveen, because you mentioned about this green AI aspect here as well, and Srini was mentioning about the AI workload. And on the other side, you are also looking at how you can use LLMs to optimize energy efficiency. So I want to understand how they go together here, right?
Oh, that's an interesting question. So from a green software perspective, right, what we are trying to do is we're trying to optimize, right? It's basically an optimization problem to lower your carbon emission, right, and increase energy efficiency. And if you look at probably from an AI perspective, there are two classes of model we look at. What we call classical AI, which and generative AI. Classical AI is the standard machine learning where you do experiments, write recommendations, and so on. And we look at, and if you look at that from an efficiency green software perspective, there are various aspects of you can bring in from a green software perspective. For instance, how do you do training optimally using the right set of hardwares? Now there are various standardized chips available, right, which can be deployed both at the training time as well as inference time to lower your carbon emissions. Right, from a data augmentation perspective also a lot of experiments have been done, right? How do you do data augmentation and training in a way that is more optimized? So from a classical angle, there are a lot of strategies you can build in from to bring in green software aspects and lower the carbon impact. Now from a generative AI perspective, again, I mean, it becomes interesting because from a large language model, there are again two parts to it. Whether organizations are building models, that's what three players I would say, right, in large language models. One is organizations that are building large language models, whether it's DeepSeek or R1 and so on, right? And the way they build models need to embed all of these principles. Like DeepSeek is a classical example where they try to reduce the cost impact by using a different architecture as well as reducing the training time. Also, they optimize at the hardware level. So they use GPUs as well as, and they looked at efficiency at the CUDA level itself, which is the native programming language. They try to build in efficiency at various levels, and this actually can be good research problems to solve, right? How do you do optimization at both the hardware level and the software level probably from an optimization perspective. Then there are organizations which are fine-tuning it. I mean, taking the model and building on top of it. Like you see retrieval augmented systems being developed and so on. Again, in that, how do you build in the whole energy aspects, right? If you're now there are various storage mechanism available, right? Vector storage, provide all of these capabilities. But a lot of software engineering aspects comes in terms of how do you do optimized query, how do you do caching and so on. So that's the aspect organization can follow. And third is the usage side where organizations are just using an LLM provider. Like when you use ChatGPT system, right, or using a user interface, you're typically calling a ChatGPT system. But primarily from a programming perspective, there are various aspects you can build in from a large language model. What we call as something called green prompt engineering, right, where if you are giving prompts to a LLM system, how can you make it greener so that you could avoid a round trip? Like for instance, if you're asking 10 queries to the system, can you compress it to 1 or 2 queries, right? So that's the innovation you can bring in. Now something with Sridhar touch upon, like if you're using LLM, right, to generate code, now there are prompts available now, green prompts we call it, right? So when you're generating a code, you can prompt the LLM to generate a code which is much more optimized for carbon efficiency and increase your overall, utilization and so on. So you're now using an LLM not just for generating a code, but generating a code in a way which is much more efficient, and that's where the green prompting comes in. So I would say it's basically a trade-off. LLM will give you, you just need to balance how can you best use the systems, right, for your advantage.
That's a very nice point, Naveen. Thank you, because there was one tweet in X platform. It's not Twitter anymore, whatever. So they said that why don't you show somewhere, the carbon footprint of every query that you write in GPT to make people more aware of how much, emission is happening whenever you are writing a query and when a response is being generated. Can we say that, okay, now you are writing this query, you are killing this many trees, right? I don't know. I mean, this was one tweet that I found very interesting. And to the point that you mentioned about optimizing queries in such a way that you get green code, right? So this is also some research that we are also working on. So very nice to know from you about that. Now, taking this little further, right? Because you mentioned about, we have been talking about green software, we have been talking about how you look at metrics, but one of the challenges I see is organizations adopting this, right? I've been Like for example, I've been part of some panels with multiple organizations, and the moment you talk, everyone are very interested to talk about it. Everyone are interested to show the digital carbon footprint, but how much of it is getting adopted is always a question. So first I would like to start from Sridhar a little bit on that note about, one is the adoption part, and also about, you have been involved in this BIS, standard working group, I suppose, where you are trying to come up with a standard. So do you also see that this kind of standards might help industries to adopt, or is that a way that you are thinking about it?
Yeah. Before that, if I have
Sure,
just
sure,
one,
definitely.
So
Yeah,
I think just want to touch upon on like, so I think the efficiency thing that you started. I mean, that we've discussed. I think I see the need to come up with architectures that leverage, right? Probably the classical or rule based and LLM based. So if you say like, okay, for everything you go with LLM, like maybe the end users, right, may not know whether it is LLM or rule based. So I think it's on the software engineering side where the thought has to go beyond like the programs per se, and then say like here is an architecture that leverages whatever it leverages doesn't really matter. So even if you say ChatGPT might use 80% rule based, only 20% LLM.
Yeah.
It doesn't really matter. So I think there is a definite need that I strongly believe to move into the direction where the systems have to go to this trade-off.
Yeah.
Right? Do I really need an LLM or not? That's not for the end user, but it's for the software engineer
to figure out.
engineering team to figure out, right? So again, just to extend that further, and then I'll connect to this is, so let's say when you do a query on a database, for example, right? Now we moved from the SQL or the relational database to NoSQL, right? Do you really need NoSQL in all contexts is the question. But now if you look at it, like MongoDB is one of the most popular databases, right? We have done some experiments in this space to figure out, like we actually built a tool called dbjols. Again, the idea is to figure out, like if I write the query in this particular way, can I do query rewriting, right? Such that it consumes less energy, right? So I think there are, I mean, again, just to close on this line, right? There is a need, again, on the line of the software engineers, from SEI, which is a little generic, to the software engineers who have to design this architecture and design space, right? So I think that's an actually important thing, which is critical for adoption. Because what happens is, if this design is not done at the organization level, then the software engineers or the programmers, they're doing like, okay, maybe a tweak in the programming language, or sorry, program that they've written, or like they're looking at it. But if you say that you design it as part of the architecture, and that becomes a decision, then probably that might help in the adoption a lot more, because it's part of the process that is there. So whenever you write a program, there is static code analysis tools, like there are many tools that check. Now there should be a tool which will check for sustainability, right? That's when, if it is part of the process, then hopefully, like there is a thing, right? And again, the challenge is like, again, it's a trade-off in terms of, do you want to regulate this? Like for example, like GDPR or DPDP Act now, versus like so it's a challenge. So let's say if you go till the regulation, then it might be challenging for many software organizations, right, to actually and say that no, we are compliant with this, right? I would personally believe that we are a little bit far on that regulation thing and imposing that regulation that you do, because we need to have mechanisms before we actually go into that regulation right away and say, okay, you have to do this. And these mechanisms have to be looked at from multiple perspectives. One is from the software organizations who are going to design, develop and deploy, but also from the software engineers perspective. Can we give them a catalog of patterns, right, which they say like, okay, if you follow these patterns, probably your software might be a little bit more sustainable, right? So there is or like I see a need for from both the software engineers as well as this, right? And that's where like this group on green software within the BIS, Bureau of Indian Standards, and of course at the ISO level, the idea is to SEI is on one side, which is to generic, if I may have to say, like at the organization at a very high level. On the other side, we are talking about RAPL, like, or our R joules or DB joules or any of these tools, which are more close to the software. I think there is a need to have something in between, right? I think that's where I see there's a lot of opportunities, both from research as well as building tools and practices.
Great, Sridhar. I mean, in fact, the point that you mentioned about the onus is upon the software engineering team. That's why one of the things that Raghu was mentioning during the presentation was about this concept of model switching, where you abstract away the concept from the end user and you switch behind the scenes so that you're always looking for an optimal option. I think more research needs to be done in that space. A very good point. So Srini, one thing that, extending what Sridhar mentioned about this organization, right, and then I'll come back to Naveen on this, is this idea of organizations adopting this, right? So I was in one roundtable where there was a guy from a bank and he came and said, Karthik, this is great. Energy efficiency is wonderful. We want to contribute to the environment, but what is the ROI? If I go to my organization and say that, okay, let's change the architecture of the system and then make it more greener, or change my programming language, it's not easy. I mean, I'm talking about a big change. We're already having enough legacy systems and so on. So what are the struggles you have faced, or have you faced any struggles? Or also, have you seen some light at the end of the tunnel where organizations are ready to adopt such kind of standards to show their carbon footprint?
Thanks, Karthik, for asking this question. Definitely there is a struggle, right? And let's not mince words here. But then I think we should look at it a little different. What organizations and businesses want to do, they want to make money, they want their stakeholders to make more money. Simple, right? And we obviously, when they recruit people like us, they want to give us more money. Simple logic. What sustainability has traditionally been pitched as is an ESG initiative, something that the organizations have to do to put at the end of the year their financial reports that they have emitted 1,000 carbon tons, whatever. But there is also a catch. Today, organizations can buy carbon offsets at a price. For that 1,000, they can go and say, I can buy 1,000 carbon credits, which means their net emission is zero. So this concept of net zero has to be looked at it very differently. While we keep talking about how do we reduce emissions, organizations look at, I would say, a different alternate route and go and buy these carbon credits and make their emissions net zero. I think there is an opportunity for both anyone who is willing to put that effort to go and pitch to organizations to look at it as a cost savings initiative.
Okay.
While we today are looking at it as a goodwill initiative, if we flip the story around and say, hey, you have this number of systems in your landscape, this is contributing to so much of emissions. If you do these XYZ sustainable software initiatives, is it going down by 5%, 10%, 15%? You know what, we all know what Trump is doing today, right? So the cost savings initiative really will hit home with banks, retails, because everyone is trying to reduce their margins. Yeah. I think that story is not well told yet. I think there is an opportunity within the organization, with academia, with startups to come and tell that story, pitch a startup story maybe, and say, if we reduce your tech debt by so much, is your cost of operations going to go by X%, Y%? I think that story will be well sold.
So sustainability is more like a thing that happens implicitly, you don't make it explicit, but at the same time you put cost as the main.
Exactly. Like a couple of years back, or not, 5 years back, I'm sorry, I'm continuing, we all heard of accessibility, right? People thought accessibility is a good thing. If you make your applications color friendly, or if you make it RGB, all those things, people thought you're doing something good for the society. But there was a research, I do not know, but Apple latched onto that and said, if I make my applications more accessible, there is a good segment of our population who will buy my phones. And that's what they did. Today, accessibility, there are product managers who come in and pitch accessibility, and if your application is or product is not accessible, it doesn't pass the test. It cannot be released into production, whether it is Microsoft or Apple or Amazon, doesn't matter. If you're not catering to that segment, it means you're losing a big market segment. So that same story can be done for a sustainability.
Great. I mean, so then sustainability becomes a highlight there. That's very interesting. So You said about this tech debt reduction, and that's when I want to go back to Naveen here, right? Because you can also talk from an Accenture perspective, because one thing is green by design and one is green by retrofitting. Because most of the time, if I want to pitch this story saying that, hey, I'll reduce your tech debt, which is, just to give an idea, many of my software systems are old software systems which are with outdated technology, and I want to update it to newer technology. And that requires a lot of cost in terms of manpower, in terms of time, effort, and so on. So if that is probably a way to pitch sustainability, then the question is also, will companies be okay to look at from a sustainability angle? So when you do retrofitting, how hard it is going to be? Because most of the time it's easy to build a system ground up, fresh as a greenfield system, looking at sustainability. But I have a legacy system, now I have to bring in sustainability, and that's, I think 80% of today's software systems, 70 to 80 are legacy systems. So how do you look sustainability for those kind of systems, right?
No, that's a very good question. That's a relevant question. I just want to touch upon the adoption angle first. So if you look at from a green software, right, primarily from an organization perspective, it's more about a culture change. I would like to call it more of a culture change, because now you need organization as well as developers, right, to embed sustainability as one of your core aspects to it. And that's where I think the leadership buy-in comes in terms of how do you make sure, right, sustainability gets embedded into whatever work is being done as part of design and development perspective. And then what we talked about, right, tools and technology are definitely important, right, to ensure that whatever tools are available is it's available to all the developer community, so that they could do the sustainability work day in, day out. Coming to the legacy problem, I think, it's an interesting problem, because now I think organization have an opportunity, right, to look at their existing code base, right, and use levers like green software and AI to transition the system. Because at some point of time, they have to upgrade systems, like whether it's a new version of a Java package or things gets obsolete and so on, right? So I think these are all levers which an organization can take, and they can basically start small. I gave the example of moving from, let's say, from Node to Rust, right? Similar, we can move from COBOL to a more efficient language, transition to cloud, and so on. So a lot of using Copilot route. Copilot now makes it easier, right? So there is not a skills challenge no more, but you can design application which can help you move to cloud faster or move to energy efficient language. And definitely going green, both, in terms of software engineering and AI, will definitely lower the cost. So it's not just transitioning to a more efficient system, but over the longer run, it's a high, looking at from an ROI perspective, it will lower your cost also.
Oh, great. That's a very interesting point, because I feel that, when we are talking about generative AI, one of the things that could come as a hand here is the productivity gain, if at all we reach there, right? If I want to migrate a system, if it takes usually 10 years, I know a company was estimating 1 year, how much time it will take, and they said that the estimate is 15 years to migrate. So maybe with this, if we can reduce that time by 5 years or 10 years, then you're essentially talking that much carbon footprint is also saved, right? You can offset it. And the other way to look at this. This offset is very interesting, because I also feel that sometimes industries buys this offset from, maybe I'll plant some trees so that I can, consume more carbon footprint of my software. And this is called greenwashing, in some sense, right? I also see this happening a lot. But anyway, you want to add something, Sridhar, here? Yeah, I think that you want to say.
Yeah, it's very interesting, again, on the legacy systems line, right? Whether you want to migrate, whether the business want to migrate, of course, I'm not an industry person per se, but we have collaboration with IBM folks. And we try to, the challenge was there's so much of COBOL code out there. Of course, some stats say 93% of ATMs still run on COBOL code. I don't know, the current figures, right? The challenge was really to we don't have so many people who understand COBOL code today, right? So coming from, again, the point of okay, even when you do the migration, I think now another direction that I'm seeing in the context of legacy systems is, no, we don't want to migrate our systems. Okay, can you use your LLMs, your generative AI stuff, and still ensure that no, our systems are good enough.
Oh, like that. Okay.
So this is a very recent thing. We actually try to build tools on COBOL, like to understand COBOL code, extract things from it. But now suddenly, we're seeing this slow change in the thought process.
Okay.
Now, one of the things that I was thinking during this was, okay, can we, make your legacy system itself sustainable, right?
Yeah.
So I think in software engineering, right, like we have refactoring, like, where we don't affect the functionality but just do, right? But can we do this refactoring from a sustainability perspective, right? This is something like, an interesting line of work that, we would like to explore, right? Because you're not saying like, okay, we'll do migration and stuff. We take a legacy system and then start looking at it. Then say, okay, it's the same legacy system, but it is a little bit more sustainable now.
Great, great. So yeah, if there are software engineering students here, you understand why refactoring is important and refactoring with sustainability makes more sense. Thank you, Sridhar, for that point. So we have like 7 minutes left. At the end, I would like to, if you have some questions, feel free to raise your hand. I'll come back to you, right? Okay, great. So I'll come back to you. I'll quickly, get their thoughts on the awareness aspect of it, because that's, something that we also have to discuss, which is about how do you create awareness, right? We know we have been talking about green software and so on, but I think that still there is a lack of awareness. So maybe I want to start with you, Sridhar, because from an education side, right? I was in EPFL a few weeks back, and I saw there was a paper that talks about sustainability in education, and it seems that students were able to feel that when they learn sustainability, they are feeling that somehow they are contributing to the environment in some way. So do you think that we need some kind of curriculum changes, or maybe by introducing sustainability as a core concept in some of our teaching courses and so on?
Right. Just to, for example, on GitHub we have stars and forks. I think we should have energy stars. Right? That's the way, and when every project is being evaluated, let's say, software, right? So there should be score for, from an energy perspective.
Yeah.
So I think slowly as we start, if we directly connect, again, the value add at least in the, from a student's perspective, right?
Quick, yeah.
Okay. Have some percentage of evaluation for,
optimizing code from energy standpoint. Okay. I'm going to take that.
But on a bigger thing, right? I think with more and more services, even across the government, like e-governance and so on, right? There should be these badges, or this is how I'm looking at it.
Got it.
We should have some way, like electric appliances.
Some
have
tag,
badges.
some star rating.
Some tag, some star rating, something like that, might
Softwares.
probably, bring some awareness.
Nice. Naveen, your thoughts, for awareness?
No, I like the batch approach, what Sridhar mentioned, right? With, I think with the new specs with SCI for AI, right? We are trying to look at how we can extend SCI to AI, and there is also looking at how we can do ratings and evaluation, right, for various systems. So that's in the pipeline. But awareness, I think, as I mentioned, both aspects, right? One is at the org level, more of a culture change, but I think it's a developer mindset, right? So having these kind of sessions is helpful, and I think more from a developer community or practitioners, right? I think whenever you design something, right, just ensure you now keep all these aspects in mind, because we don't need to have a regulation to say that we need to write a better code, right? From a developer standpoint, we just ensure whatever code we write is more energy efficient.
Srini, your thoughts, because I also want to know from a product manager. See, when you're recruiting students, we are only asking DSA questions. Let's be honest here, right? Most of the initial round is data structure algorithm. So there has to be some incentives for probably also the students or the new developers who are coming in. Maybe why I'm asking this is if we imbibe this kind of concepts to their education, and maybe the process also encourages students with some sustainability mindset to come into the orgs. You think that kind of a change can happen, or something is being under consideration?
No, definitely great point. I think when Dr. Sridhar mentioned that projects given as submissions to the students have that angle, what is your sustainability story in this project? We ask questions, what is the performance? What's the throughput?
Yeah.
If there is a sustainability story, I think I will go back to that Apple story I said. If you make that as part of your habit, it should be easy. If we try to make it explicit for the students to learn, I think it's a great idea to have a sustainable software engineering course, by the way, but that should go hand in hand with your data systems, with your operating systems, with your database architecture, so such that there is a chapter in those courses as well that touch upon sustainability. If you're writing a query, you should understand that you do not have infinite resources behind the scenes to run your query. You can't have an infinite loop running in your code, and you expect the infrastructure to take care of it. So I like the idea of integrating it into the course curriculum, so such that students write better code.
Nice. I think we have some questions before we end. But just before that, I mean, for people interested in Hugging Face, they have recently released something called carbon footprint. For every AI model, they are now showing what is the carbon footprint of the AI model, right? So these are some efforts that are going on. There are also courses in some universities focusing on sustainable software engineering. Maybe we might also offer something. But great points. So we can go to the audience questions now.
Thank you for the great discussion. So from the software point of view, we have been trying to optimize on energy in the SCRC lab. What I think is, we have a testing layer when the software has been deployed. We should have another layer where we measure the carbon footprints, the carbon emissions, and shouldn't the government have a body that monitors the carbon emission for each of the product by a company and have restriction or thresholds on it? Plus, the next point is that the philosophy of technology has been changed over years. First, the technology was developed for a specific reason. It had a reason, and then the development phase. What is being done today is, the technology has been first developed, and then we go and find a reason where to implement it. Should this be changed back to the past system? And sustainability in the novel side of you, like sustainability for the technology which has already been developed is a major concern, because the new technologies have been replacing it for a while now. So how do you propose that that has been implemented as the
Yeah, I think I'll go with the second part first, right? So I think there are both of these sides, like, how do you make your existing technology sustainable, right? How do you design your technology in a sustainable way? I think both of these are critical, and I think we need to figure out. So one thing, as we have more and more mechanisms, right, to design technology in a sustainable way, right? So the practices of how do we maintain, especially in the context of software, right? Because most of the time goes in maintaining and extending the systems, right? The process itself might change, where you may have steps, you may have tasks within the software development process, right? Especially during maintenance, right? Where you're going to look at it from a sustainable, perspective, right? And for your first comment or question on this regulation, should the government do? I think there are initiatives, right, which are again so for example, if government says ISO ACI, if you are producing software, ISO ACI, it should be ISO ACI certified, right? So the regulation might happen, but like I think I've said earlier too, right? The changes in the process are not there yet. If the regulation is imposed, right? Say for example, if you say like, okay, you can't use your smartphone from 9 to 5, right? If there is a regulation right now, it comes, right? It will be a challenge, right? What are the alternatives? How do we change the process, right? To be able to do that is the key. Hopefully.
Just want to add one more answer to that. So the first point that you talked about in terms of regulations, very interesting. If you're buying a smartphone today, you will have a spec there called SAR ratio that tells what's the emission component, what is the impact of that phone's manufacturing process on the environment. I think as a product manager, one of my wish lists, it's not there, is if you go to Android ecosystem and you see Candy Crush or Subway Surfers, I want to see the emission component that has gone into building that app. That will be the ideal way to go, and you can choose, because as long as you give the customer or the consumer to choose between, you will never hit that scale. So if that's a wish list.
Yeah, thank you for a great panel. But once again, I have two questions, but the major question, maybe I'll just go back to my notes that I have. Professor Sridhar pointed out 2 points. When it comes to mechanisms, maybe can we have catalog of patterns to be, to make the software systems more sustainable? And the second point is to make legacy systems itself sustainable. So these are the 2 points. So my question is, can patterns be used in a more dynamic, adaptable way rather than just being applied rigidly by just giving catalog of patterns? I mean, like, shouldn't we look at how to develop a sustainable driven architectural pattern selection framework that adapts based on system constraints and operational conditions? And if sustainability conflicts with other key quality attributes like performance, cost, or scalability, will it ever be truly prioritized? I mean, sustainability in the first session. And how do we balance this drive for economic growth and technological advancement with the urgent need for sustainability and climatic action, ensuring that progress does not come in between the environmental challenges that we are trying to solve today?
Yeah, I just want to say that these are these are very good research problems to solve. I mean, this is exactly, I think, which, these are very good research problems you mentioned, right, that needs to be solved. Coming up with an optimized systems, right, which takes care of sustainability, looking at both cost, performance aspects, right, it needs to be developed and built. We need to have use cases, case studies, right, which can augment that.
I think if I go very fast, right, in the interest of time, right, I think the catalog patterns by design evolve over a period of time, right? You start with a catalog of patterns, but then over a period of time, if you think that, okay, the pattern, has to be revised. So I believe that, in this space, there is need for many more patterns. So we only know a few of them, right? So I think that's definitely an area where, this catalog should be built. And of course, they should be looked at depending on how they are applied or practiced, right? And on the second point, right, I think, yes, the way I look at it is, like we have technical debt, there should be sustainability debt, right? So, or energy debt, like, whatever you want to call, right? You make this decision because you want it to run immediately, because that has to be run. But you know that if I do this, it's going to cost me energy, right? It's not sustainable, right? Slowly, the system might progress towards that. I think that should be explored through experiments. We don't know yet if there is a correlation between that. At least I don't know that yet.
Hi. So there was this concept of awareness. Yeah, there was this concept of awareness which Karthik sir had talked about in the end, and Professor Sridhar, you mentioned about badges and all that kinds of for organizations and products, right? So my question is, when we also talked about is sustainability as a practice only from the developer side or from the user side, do you feel that there should be some role allotted for the user as well? Because again, they are the users of the product, right? So what I mean from this is, suppose if I open ChatGPT right now and it gives me an option to switch between models, which is also what we are working at. But essentially the user defines your quality of service, right? So if I also tell the user in the model itself, in the website itself, that, hey, you are using O3, but it is better, yes, but it is also how much more impactful on the climate, which is not there right now. Do you not feel that they would also feel that I might not need this much quality of service, but I might also contribute more to the impact? Because in the era of GDPR and data control and all that, where users are so much prompted with consent and data control, shouldn't you also prompt them with awareness of the environment? And another question is net zero software feasible for every organization, and how would you impact the assessment? How would you do it for a particular organization? That would just lead to disruption of service. So that's what my question is.
Yeah, okay. So again, so I think that's a very, very interesting point, right? Like, I think from the user's perspective, I definitely see that there could be an act that may come later, right? For example, if you fly now, right, you will see what are the carbon emissions. Similarly, it may happen, but right now, at least as far as I know, it's not there yet. And one of the reasons is we are probably at the early stages, right, of even this generative AI from a user's perspective, right? But I think if you have to have that, again, I'll go back to my metrics thing and say that, we need to really come up with metrics that make sense from a user perspective, right? So organizations, again, maybe, I'm an academic guy, right? They come up with, smart metrics which will show that their thing is efficient, right? But I think there is definitely need to come up with, those kind of metrics.
Yeah. So one of my questions is, typically we have like two kinds of software. One is where I'm an organization, I deploy it, and it runs in my service or something that I pay for. There is other kinds of software where we give it to a client. For example, to take a better example, games, for example. Game gets built once, but they're played by millions of users and played on their own hardware. So here the sustainability is not technically measurable in the first place, because like as an organization, I don't need to say that, okay, I'm estimating 1 billion sales this year, so this will have this much emissions. So that is never a metric that anybody gives out. And the same thing happens for like trivial cases like JavaScript. There is like JavaScript is very bloated in a sense, but we can't really change it because it's there everywhere on the web. So if a company decides that, okay, let me offload the entire computation to the client, right? Let it happen on the client. So in which case, company is not bearing any of the sustainability cost. As a client, I am bearing the complete sustainability cost of it. So, and even though I don't have any control over the software, I can't change the web page. But my only option is whether to use it or not use it. But I might need that service, so I'm like, okay, this is like accept all terms and conditions, like, and no other option other than that. So traditionally, games have been better at utilizing the software better. So even like when in 2012, when GTA 5 or games like that came out, they are like 70 GB games which can't even fit on a single RAM, right? And nowadays we have RAMs that are big enough, but games have always been in that way where, oh, let us use the hardware to its fullest. So they have always had that direction, even from retro, like from 1970s they had that direction where hardware is not there yet. Let's just build a bigger software. Let's optimize it for that. But if you look at current softwares for web development and all, where we are like, okay, our hardware is powerful enough that I can not be very efficient. So that's kind of the direction that things went. But now we have like games which are almost 100 GB that run on mobiles, right? So games have traditionally been in that space where they're optimizing for the maximal usage of hardware. So I want to talk about like this kind of a progression where what if companies just give out a software which client uses? So how are we able to kind of measure sustainability in that regard? I want to give it out question so that you give consideration to that aspect as well.
Thanks for that question. This space, fortunately, is well developed. Why I say that is there is this concept of scope 2 emissions, there is this concept of scope 3 emissions. When you as an organization are building a software that your own internal team uses, that is your scope 2. When you are building an organization, when you are building a software that you expose for customers to use, the building part of it is your scope 2. Once customers start using it, it is their scope 3. So why I give this differentiation is this accounting, I'll call it accounting of emissions, is not diluted. There is always a record of who is building it, who is using it. So if you are building it, and if you are, like for example, take any cloud provider. Any cloud provider is providing a host of services. And for building that host of services, it's their scope 2. But once you start using a Lambda function or an EC2 instance, it becomes your scope 3 for you to manage. So if you see, all these cloud providers will have a disclaimer. Our software development, we have taken care, but if you want to be sustainable, you put in measures in your software development lifecycle as you use these services to make your customer friendly. And that's where, if you take one of the premises of Green Software Foundation is, if you take any open source software, like for example, Log4j or any TensorFlow, they'll say how many ever times that open source software is used in how many ever applications. It is not counted once, it's counted n number of times. The rationale for that is you need to start reducing it your application level. It cannot be at that open source software level. I mean, that's one way of looking.
Yeah, so great. I mean, thank you so much for all the questions. I know that there are still some questions left, but please, you can take it offline. So just want to end on this note. I mean, we have still a lot of research that could be done in this space. So this is an area that is getting picked up, but at the same time, now I think there is a lot of awareness that is coming through. I hope these kind of sessions and maybe introducing into the curriculums and all will help more to spread the awareness and in terms of how much software contributes to the environment. There is also this notion of embodied carbon, which we didn't discuss. Thanks for you to putting up this idea on scopes. This is also something we couldn't cover. But anyway, thank you so much for being a wonderful audience and for asking great questions. I really enjoyed this panel from my side. Thanks to the panelists, Naveen, again from Accenture, Sridhar from IIT Tirupati, Srini from Microsoft. Thank you so much for this engaging discussion. I hope we can do more of this in future as well. Thank you.
Thank you to all the panelists for this very insightful session. I'm sure we all had a lot to learn. I would like to call upon Professor Aftab Hussain, Chair of R&D Showcase, to felicitate the panelists. Sir, I would like you to address the gathering as well.
All right. Thank you everyone for coming and attending the inaugural. It was a great talk, great panel. Right now, I just want to announce that the R&D Showcase is officially on. We will have the showcase all the way up to 6 o'clock in the evening. So you guys are free to move around, look at all the rooms. There are all posters, demos. There are almost 300 plus. That are basically, showcasing all of the research achievements that we have in IIIT and all the research output that we have. We are very proud of it, so please go around and have a great day. Thank you all for joining.